Astable multivibrators are free-running oscillators which oscillate between two states continually, producing two scalar wave output waveforms. Which means this. To understand this circuit, let's start with the most essential components. We have two load resistors here, which limits the current that goes to the load. In this situation, the load is two LEDs here, and these resistors limit the current which will go to the LED. And there are two other resistors here, which sets the frequency of the circuit with the value of those capacitors. We have two NPN transistors here, which I used 2N2222. Imagine that we stop the time at the beginning of an oscillation period and assume that Q1 is on and C1 is fully charged. As Q1 is on, this line will be connected to ground. Left side of the C1 will be 0 volts. And this side of the C1 will be negative 4.3 volts. I will explain why this is like this. We have negative 4.3 volts here. It's the same line with the Q2's base. So we have negative 4.3 volts here. So Q2 will be off. And C2 will be almost empty, and it will charge through R4 from this line. C1 will discharge from this road through R2. R2 has greatly higher resistance than R4, so C2 will fastly charge through R4, and we will have 5 volts here. And as because of Q1 is on, its base is 0.7 volts and we have 0.7 volts here. And so we can say between two sides of this capacitor we have 4.3 volts of potential difference. C1 will be discharging through R2 from here to here and then here. So this side will be rising. And when we have 0.7 volts here, we will be already at 0.7 volts here and 5 volts here because R4 is smaller than R2. This side is reached 0.7 volts and this is the same line with here, so we will have 0.7 volts here. So when this is 0.7 volts here, Q2 will turn on. And this line will be directly connected to ground, which means we will have 0 volts here, 0 volts here, 0 volts here, and 0 volts here. C2 was fully charged and had 4.3 volts here, so we have 0 volts here. So we can say we will have negative 4.3 volts here. This might be complicated, but don't forget that voltage is actually a potential difference. We still have 4.3 volt difference between C2's two plates. So this side is connected to ground, so this is 0 volts, and this is 0 volts. This side have to be negative 4.3, and this is connected to Q1's base. We will have negative 4.3 volts here. Q1 will enter the cutoff region, and now we can see that our state is reversed. Now Q2 is on, C2 is charged, and C1 is almost empty, and Q1 is off. And when this cycle goes on, as during the time the transistor on, for example Q2, for this time, the current will go through R4 and our LED through here, and our LED will be emitting light. And the thing that sets the frequency is the discharging time of C1 for this situation. At the beginning, C1 had 0 volts here, and negative 4.3 here, 3 volts here, like C1 had right now. So as C1 discharges from here, or light or LED will be emitting light. So what sets the time for the circuit is the discharging time of the capacitors. Capacitors are discharging through high resistance resistors, so the discharging time will be greater than charging time, as because of that the thing that sets the frequency for the circuit is our discharging time. And after this stage, just like this, it will go on. So now Q2 is turned on and we have 0 volts here, negative volts here, and it will discharge from here. This will charge from here. As this voltage rise up, Q1 will turn on and Q2 will turn off. And this will go on like this. Starting off, the circuit can have different characteristics because the components never have the actual value it's written on them. And resistors usually have 10% or 5% tolerance, which means this 10 kilo ohm resistors can have value between 9 to 11 kilo ohms. So if this resistor is actually smaller than this one, Q1 will be the first one to turn on and it will start the cycle. And this time will be quite short. Capacitors will be so little charge, so beginning of the cycle will have really small frequency. And after that, the circuit will turn its normal oscillation.